Okay, now we're going to we're going to have a different scenario where we look at how many users we need in our networks. So we need 7 networks this time, the same 7 networks, except our networks are different sizes. And you'll see this scenario on the CCNA at least, I don't know, probably at least 3 or 4 times, but it really applies to everything that Cisco CCNA is all about as far as like subnetting and being able to see networks, where networks start and stop. So it's really important if you're going to take that certification exam. So here you go. Let's say on this network over here we need 128 users, and then we need 2 users, basically just point-to-point links in between the 3 routers. So 2 hosts, basically an IP address for this interface, an IP address for this interface. So that's 2 IP addresses, right? So just 2 users essentially, right? IP address here, IP address there, here, 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 here. So 2, 2, and 2. Then over on this network, 64. And then over this network, we need 32 users, right? Right? And over here, we need 16 users. And it'll be a little bit different. You could actually say, well, we need 120. It'll say something like you need 120 users, or they'll say on the CCNA that you need 60 users, not 64. And this will say there's 30 people in their network, right? And on this one, not 16, but they have 13 stations with 13 computers. So we need 13 IP addresses for this network, okay? Because we can never actually get 128, we can only get 126. So let's divide the network up, and that basically what we're doing is we're essentially doing variable length subnet masks. So I'm just going to go from largest to smallest, and for the first network, 192.168.1, I'll start with the 0 network. Okay, so this will be the 0 network, and it will be /25. Okay, why is that? Well, I'll put it right here. The 192.168.1.0/25 means that on my subnet mask, I'm going to have, it'll be 128 subnet mask, right? Meaning that the binary in the last octet will look like this: 1,0,0,0,0,0,0. So I've only borrowed 1 bit from the last octet. I've only borrowed 1 bit from the last octet, and that bit is in the 128th place. So that'll make 128 users. Out of those 128 users, 126 are usable because we need the first address for the network number, and the last address is the broadcast address. So this will be the 0 network /25. Then I'm going to go to the next largest network, and I'm going to make this network, let's see here, the 128 network. That's where the next network will start, and we need 60 users, so it needs to be size 64, so it'll be /26, right? So the next network will start at 192.168.1.128, and it will be /26. Now, why is that? Well, /26 means I've borrowed 2 bits off the last octet. In decimal form, it would look like this, right? 26, 255, 255, 255, 192, meaning 8 bits, 8 bits, 8 bits. That's 24 bits here, and then I borrowed 2 more, 25 and 26, right? The magic number in this case is, this is the 128's place, this is the 64's place. The magic number is 64, so I'll get 64 hosts or 64 users out of this network, okay? The next one I'll go to will be the next highest one, 30 users, and that network will start at 192, just like it says right there, and it will actually be /27. Okay, so that'll be 92.168.1.192/27. The magic number in this case, right here, will be magic number will be 32, 128's place, 64's place, 32's place. Magic number is 32. In decimal form, it would look like this, and it would give me 32 hosts. Okay? The next network over here, let's say, of 13 users, which we'll go to the 16-bit. So this one will start, let's see here, 192 as 32, will start at 224. It'll be /28, and it'll give me 16 users. All right. In decimal form, it'll be the 240. The binary would look like this. We borrowed 4 bits now. It's actually a /28, right? And I'll put it up here too. 192.168.1.224/28, and that means the magic number is now 128, 64, 32, 16. It'll give me 16 hosts starting at 224. That's the network number, and 16 hosts from 224 to 239. 239 will be the broadcast address. So that leaves me for my last 4 networks. Let me see how much time I have. Okay. For the last 4 networks, we'll count 16 up. 224 plus 16 is 240. So the next network will be 240. And this time what I'm going to do is I'm going to jump all the way over to a /30 because I only need 2 hosts, 2 usable addresses, which is perfect for a /30, which gives me 4 hosts, 2 of which are usable. So that works out just perfect. So starting at 240, I'll do a /30. So let's put it here, 192.168.1.240/30. In decimal, it'll be the 252 network. And what this looks like in binary is this. So I've borrowed now 1, 2, 3, 4, 5, 6 bits. The magic number is the 4-bit, which gives me a network the size of 4 hosts only. So there's that. Now, the last 2 networks are pretty simple. This one right here will be the 244 network /30. This one will be the 248 network /30. And all I have to do is add those in. So the next one's 244. The following one is 248 /30, and the last one 248 /30. So now I have 7 networks, right? All are a different size subnet mask, but none of the networks cross over. In other words, they all use a different address space that's not conflicting. And that's a variable length subnet mask network. We used a /25, a /26, a /27, /28, and 3 /30s to get networks to accommodate the size of 120 users, 60 users, 30 users, 13 users, and 3 point-to-point links in between.